Friends, today we are going to learn the inverse of a square matrix. In this class, we are going to learn inverse of a square matrix definition and problems related to that. So, what is the inverse of a matrix? Inverse of a square matrix. If for a square matrix capital A, there exists another matrix B such that AB equal to BA equal to I means identity matrix, then the matrix B is called inverse of A, and A is said to be a invertible, and inverse of A is denoted by A to the power of minus 1. A inverse, it is read as A inverse, A to the power of minus 1, A inverse, that is B equal to A inverse. Okay, the square matrix A, for any square matrix A, if there exists another matrix B, అంటే ఇంకో matrix B అనేది ఉండాలి, such that ఏ విధంగా ఉండాలి, it is exists such that AB equal to BA equal to A into B, that is AB equal to B into A, BA equal to identity matrix, then the matrix B is called inverse of A, inverse of A, and it is denoted by A to the power of minus 1, that is B equal to A inverse, B equal to A inverse. Okay, let us see how to find these notes, some important observations, and how to find this B. Direct we have formula in the problems. Next, note A into, we have, if B is the inverse of A, then AB equal to BA equal to I, identity matrix. What is the B? B is denoted by A inverse. B is denoted by A inverse. If you replace B by A inverse, A into A inverse, B by A inverse, A into A inverse plus equal to A inverse into A equal to I. That is the first note. A into A inverse plus equal to A inverse into A equal to I. And the second one, inverse of a unit matrix is itself. If you find inverse of a unit matrix, it will come as the same matrix itself. Third one, A inverse whole inverse equal to A. And fourth one, inverse of a square matrix, if it exists, it is a unique. If it is exists, it is a unique. Next, fifth one, AB whole inverse equal to B inverse into A inverse. Suppose if it is a 3 matrices, A into B into C whole inverse equal to C inverse into B inverse into A inverse. In reverse order it will come. Next, these are the observations. Next theorem, how to find the inverse. If capital A is a non-singular matrix, if capital A is a non-singular matrix, then A inverse, to find A inverse, it is the formula 1 by det A into adjoint A. 1 by det A into adjoint A. Means we need to find det A, determinant of A and adjoint of A, and substitute in this formula we get A inverse 1 by det A into adjoint A. That's why 1 by det A is in the numerator. If it is 0, it is undefined. 1 by 0 means infinity, not defined. So infinity, that's why it must be non-singular, means determinant is not equal to 0. Means if A is a non-singular matrix, then A inverse is 1 by det A into adjoint A. It is the formula. Okay, next. If capital A equal to 2 by 2 matrix A, B, C, D, then what is the formula for any square matrix? A inverse equal to 1 by det A into adjoint A. What is the det A of 2 by 2 matrix? AD minus BC. AD minus BC. 1 by AD minus BC. And what is the adjoint of A? Adjoint of A is D minus B minus CA. Both, we have to multiply both 1 by AD minus BC into D minus B minus CA. it is the adjoint of A. Multiplication total, it is A inverse. How to find adjoint? Already we in the previous class we discussed the adjoint of A. Det A is also in the previous class. We have to multiply 1 by det A, 1 by AD minus BC by D minus B minus C A. For 2 by 2 matrix, if you remember this as a formula, we can find directly A inverse. Otherwise, you have to find det A and adjoint A and substitute in the formula. Okay. Now problems. Find the inverse of the following matrices. First matrix A equal, first matrix, it is given 2, 5, minus 1, 5. So let A equal to 2, 5, minus 1, 5. We know that already in the previous slide we discussed the formula. If capital A equal to A, B, C, D, 2 by 2 matrix, then inverse equal to 1 by AD minus BC, D minus B minus C, A. It is the matrix. Here what is the A value? A, B, C, D. A equal to 2 and B equal to 5 and C equal to minus 1 and D equal to 5. Okay, A equal to 2, B equal to 5, C equal to minus 1, D equal to 5. So substitute these formulas in this one, we get 1 by AD minus BC. A into D. A means 2, D means 5, 2 into 5 minus BC, AD minus BC minus 5 into minus 1. D 5 minus B minus 5 minus C means minus of minus 1. A means 2. So simplification, now to simplify, 2 into 5, 10, minus 5 plus 1 plus 5 means 10 plus 5, 5 minus 5, minus of minus 1, 1 plus 2, 1 by 10 plus 5 means 15, 1 by 15 into 5 minus 5, 1, 2. This is the A inverse of the matrix. Or if you multiply with 1 by 15, we get 5, 5, 3, 15 means 1 by 3 minus 1 by 3, 1 by 15, 2 by 15. If you keep like this also, it is answer, correct answer only. If you multiply, we get this answer. Okay. Next. A equal to minus 2, 1, 3, 0, minus 1, 1, 1, 2, 0. Matrix, 3 by 3 matrix. Find out the A inverse. We know that A inverse formula 1 by det A into adjoint A. So first we need to find det A and next adjoint A, then we have to substitute in this formula. Det A means what is the det A? Det A means I am taking the first row. So plus, minus, plus. So minus 2 into, already place of minus 2 into minor. Its row and column will be removed, minus 1, 1, 2, 0. And minus 1 into its minor, column and row, 0, 1, 1, 0. Okay, next plus 3 into its minor, column and row, 0, minus 1, 1, 2. So multiplication, AD minus BC. So minus multiplication, minus 2 into AD, minus 1 into 0, 0, 2 into 1, minus 2, minus 1 into 0 into 0, 0, 1 into 1, minus 1, 3 into 0 into 2, 0, minus of 1 into minus 1, minus of minus 1 plus 1. So 2 minus 2 into minus 2 plus 4, minus of minus plus 1, 3 into 1, 3, 4 plus 1 plus 3 means 6, 5 plus 3 that is 8, it is not equal to 0. Determinant not equal to 0 means non-singular matrix, non-singular means A inverse exists. Already we written A inverse formula 1 by det A into adjoint A, 1 by det A into adjoint A. Already we calculated det A, it is 8. We have to now find out adjoint A. Adjoint A means, we know that adjoint A means transpose of a cofactor matrix. Transpose of a cofactor matrix. So we have to find first cofactors. Okay. What is the matrix? First we have to write here. -2, 1, 3. -2, 1, 3. Next. 0, -1, 1. 0, -1, 1. Next. 1, 2, 0. It is a matrix. So minor means it is plus, minus, plus, cofactor matrix, sorry. Plus, minus, plus, minus, plus, minus, plus. So first one, remove row and column, we get this one and this one. -1, 1, 2, 0. Next, if you remove second one, first row, second column, we get 0, 1, 1, 0. Next, third one, column and row, 0, -1, 1, 2. If you remove this one, 0, -1, 1, 2. Like that, it is a cofactor matrix minus of. Next one is 1, 3, 2, 0 plus -2, 3, 1, 0 minus of -2, 1, 3, 2, 1, 1, 1, 2. Next plus 1, 3, -1, 1 minus of determinant of -2, 3, 0, 1 plus -2, 1, 0, -1. We get like that. Okay. Already we discussed in the previous class. Next, its values AD minus BC plus of -1 into 0, 0 AD. Next 2 into 1 minus 2. 0 into 0 -1 plus of 0 minus of minus plus 1. 1 into 0, 0, 2 into 3, 6, 0 minus 6, 2 minus 2 into 0, 0, 3 into 1, 3, 0 minus 3, minus 4, minus 1, minus of, plus 1 plus 3, minus of, -2, 0, 2 minus 0. So simplification, -2 plus means -2, -1 plus 1, and 0 plus 1, 1, minus of -6, 6, 0 minus 3, -3, -4 minus 1 means -5, minus of minus plus 5, 1 plus 3, 4, and minus of -2 plus 2, minus plus 2 minus 0 means plus 2. That is the cofactor matrix. Cofactor matrix is 2, -2, 1, 1, 6, -3, 5, 4, 2, 2. So next we need to find adjoint of a matrix. Adjoint of a matrix means transpose of a cofactor matrix. Cofactor matrix transpose, that is C transpose. What is the C is here? -2, 1, 1, 6, -3, 5, 4, 2, 2. We have to convert rows into columns. We get -2, 6, 4, 1, -3, 2, okay, 1, 5, 2. Then what is the adjoint A is over and det A 8 we already find out. So A inverse equal to formula 1 by det A into adjoint A. So substitute in the formula. 1 by det A means 8 into adjoint A means this matrix, -2, 6, 4, 1, -3, 2, 1, 5, 2. This is the A inverse of the matrix. Total 1 by 8 into this matrix. Okay. In this, only very simple, we have to find the determinant of A and adjoint of A and substitute in the formula. Okay. We need to find det A and adjoint A and substitute in the formula. Already how to calculate determinant and adjoint A we discussed in the previous class. Okay. Next, find A equal to 2, -2, 4, 2, 3, 2, -1, 1, -1. So we know that the formula A inverse equal to 1 by det A into adjoint A. So first we need to find the determinant of A. What is the determinant? 2 into minor. So 3 to 1 -1. Minus of -2 into minor 2 to -1 plus 4 into 2, 3 -1, 1. So simplification, we get 2 into AD minus BC minus 3 minus 2 minus half minus plus 2 minus 2 minus half minus plus 2 plus 4 into 2 plus 3. So minus 5 into 2 minus 10, 2 minus 2 plus 2 0, 0 into 2 0, 5 into 4 20, minus 10 plus 20 that is 10 not equal to 0. Not equal to 0, determinant not equal to 0 means it is a singular matrix. Non-singular matrix. It is a non-singular matrix. That is therefore A inverse is a exist. Okay. A inverse is a exist. It is a non-singular matrix. Therefore A inverse is a exist. And already determinant is over, so we need to find next adjoint of A. Determinant is to find out A inverse 1 by det A into adjoint A. Det A is 10 over, so we need to find adjoint of A. So adjoint of A means cofactor matrix transpose, that is C transpose. And cofactor matrix means plus minus plus minus plus minus plus minus plus and minus, respective minus. So what is the matrix here? We have to see the matrix once again. 2 minus 2 4, 2 minus 2 4, 3 2 4, 3 2 2 maybe, 2 3 2, 2 2 3 2 minus 1 1 minus 1. Okay, 2 3 2 minus 1 1 minus 1. It is the matrix. I will explain first row, remaining you can write. So minor, first one is plus into minor, so we have to remove the row and column. We get this one, 3 2 1 minus 1, that is the minor. Next second one minus, remove this row and this one, 2 2 1 minus 1 minus 1, that is the determinant. Next third one, it will cancel out, 2 3 minus 1 1, like that. Remaining elements also same. For 2, if you remove this one, this row and column, 2 4 1 minus 1. And for 3, if you remove this one and this one, 2 4 minus 1 minus 1. Next, if you remove this second row, third column, 2 minus 2 minus 1 1. Like that we get all these minors. So calculate the minor values. So plus into AD minus BC 2 by 2 minus 3 minus 2 minus of minus 2 plus 2 plus 2 minus of minus plus 3 2 plus 3 minus of 2 minus 4 plus of minus 2 plus 4. Next fifth one, minus of 2 minus of minus 2 0 and minus 4 minus 12 plus of minus of 4 minus 8 plus of 6 minus of 4 means plus 4, minus of minus plus 4. So simplify this one, 3 minus 3 minus 2 minus 5, it is 0 plus 5, 2 minus 4 minus 2 minus of minus plus 2, minus 2 plus 4 plus 2, 2 minus 2 0 and minus 4 minus 12 minus 16, 4 minus 8 minus 4, already minus there, minus of minus plus 4, 6 plus 4 10. Okay, that is the cofactor matrix. We get minus 5 0 5 2 2 0 minus 16 plus 4 10. And adjoint of A. Adjoint of A means it's transpose of a cofactor matrix. We have to find the transpose. So first row minus 5 0 5 written as a column. Second row 2 2 0 as the second column. Minus 16 4 10 as the third column. It is total matrix is adjoint of A. It is adjoint of A. And formula A inverse equal from the equation 1 by det A into adjoint A. that is 1 by det A value is 1 by 10 and adjoint A means this matrix minus 5, 2, minus 16, 0, 2, 4, 5, 0, 10. This is the A inverse matrix. If you multiply with 1 by 10, it is also correct. Next problem. If A equal to 2 by 2 matrix, that is 2, 1, 2, 3, 1 and A square minus 2A minus 5 equal to O null matrix, then find A inverse. Already it is given, matrix is given and one condition is given, it is true. We need to find A inverse. Not direct formula, by using this equation we have to find out A inverse. So given A equal to 2 by 2 matrix 1, 2, 3, 1 and A square minus 2A minus 5 equal to null matrix. Okay, so by using this equation we have to find A inverse. Direct formula is also there, 1 by AD minus BC into D minus B minus CA. But here it is given this equation. By using this equation we have to find A inverse. So A square minus 2A minus 5I equal to null matrix 0. So I am multiplying both sides by A inverse on both sides. So A inverse into A square minus 2A minus 5I, A inverse into null matrix. We get multiplying on both sides A inverse into A square, A inverse minus 2 into A inverse into A minus 5 into A inverse into I. A inverse into null matrix means total null matrix. And A square can be written as A into A. One A is A inverse into A, another is as it is. A inverse into A equal to, already observations we get A inverse into A equal to I, 2 into I. And A inverse into I equal to A inverse minus 5 into A inverse. And here A inverse into A equal to I, so I into A, 2 into I minus 2 into I minus 5 into A inverse. This minus 5A inverse is right hand side, that is plus 5A inverse. I into A equal to A. Identity matrix into any matrix will come same matrix. Minus 2I. A minus 2I equal to 5A inverse. Therefore, this 5 will come this side. It is multiplying. So 1 by 5 into A inverse equal to 1 by 5 into A minus 2I. So we got that A inverse formula, 1 by 5 into A minus 2I. Okay. So next, A inverse equal to 1 by 5 into A minus 2I, that is 1 by 5 into, what is the A matrix? A matrix what? 1, 2, 3, 1. Okay. A means 1, 2, 3, 1 and 2 into identity matrix. Identity matrix means here A is 2 by 2. So we have to take 2 by 2 identity matrix 1, 0, 0, 1. So 1 by 5 into 1, 2, 3, 1 minus 2 into 1, 2, 0, 0, 2 we get minus 1 by 5 into 1 minus 2 minus 1, 2 minus 0, 2, 3 minus 0, 3, 1 minus 2 minus 1. It is the A inverse matrix. 1 by 5 into minus 1, 2, 3 minus 1. It is the A inverse of the matrix. Okay. Next, homework problems. Find the inverse of the following matrices: minus 1, 2, 4, 1, 1, 3, 3, 2, 3. Second one, 1, 2, minus 2, minus 1, 3, 0, 0, minus 2, 1. And third one, 3, 2, 2, minus 3, 2 by 2 matrix. Next, fourth one, A, 0, 0, 0, B, 0, 0, 0, C. Determinant of 3 by 3 is by 2 by 2 matrices, it is direct formula, 1 by AD minus BC, D minus B minus CA. For these three problems, we have to find 1 by det A into adjoint A. So first find the determinant of A, next then adjoint A, then both multiply, we get the inverse. Next problem, if A equal to matrix A equal to matrix minus 1, 2, 4, 1, 1, 3, 3, 2, 3, find A inverse and verify A into A inverse equal to A inverse into A equal to I. So first find A inverse. How to find A inverse? 1 by det A into adjoint A. Okay. After that, getting that matrix, we have to multiply A into A inverse and A inverse into A. Both the values must be identity matrix. 3 by 3 identity matrix means 1 0 0 0 1 0 0 0 1. Okay. We get this matrix. Next problem, if A equal to 3 1 4 0 2 by 2, B equal to 4 0 2 5, then verify that AB inverse equal to AB whole inverse equal to B inverse into A inverse. So first find out A inverse, next B inverse. After completion of LHS means AB, we have to multiply with AB. Then AB whole inverse, we have to find AB whole inverse. That LHS will complete. Next, B inverse into A inverse, both the values will be equal. Okay. Next, in this class we discussed about adjoint of inverse of a matrix, and how to calculate inverse and problems. Okay. Do the homework problems. Thank you.